Hi, Nikolai. Welcome back.
Hi, Adam. Thanks for having me again.
Let's talk about DOP, because the last time we spent the entire time talking about underscores, and you were really excited about underscores, and we ended even mentioning how to contribute to OpenJDK. So I hope today a little bit more around why object-oriented programming never worked, and you should absolutely forget it and just go with go-tos, GoSub, and DOP, right?
Yes. So let's talk about DOP. So we're both living in Germany, and they're legalizing DOP right now, right?
Oh,
Cannabis is getting
so you can
legalized,
officially use in Java 22 complete DOP, right?
Exactly. That's why. Yes. Get high on Java 22. Exactly.
Very good. This will be a good episode title, actually. And before you are promoting your doping, I would like to mention some object-oriented projects which worked perfectly well and were undoable without object orientation. Mm-hmm. So, this is an interesting. This is actually we met at internal meeting in a bank, and I wanted actually to discuss with you exactly this, but there was of course no time, so we will misuse a podcast for it, right?
Okay. Yeah.
So there are two projects, just to think about this, and this is hard to explain, but I think everyone had already in one point in time such a problem. So the one was imagine. ECUs, this is like circuit boards like Raspberry Pis, and they are communicating with each other. So we have ECUs, and this is Java classes, and they are connected with links. Now, there's not just Raspberry Pi, there can be, I don't know what, different hardware types and different link types. And basically what we had to implement is a sophisticated visitor pattern, right? So if you think about this, there was a signal traveled from a device to device, and there were different link types and different device types. So they started with DOP, data-oriented programming, without data-oriented programming, because it was 2005. So what they did, lots of value objects, they were called back then. The proper name would be data transfer object. And everything was full of instance with casting, of course, because we say if the signal is and the link is a fiber channel, then cast to fiber channel, and fiber channel had different properties, and then the fiber channel expected a fiber channel handler, whatever, and everything was mess, because what we did later, and this was the entire trick. This is if you use JPA, JPA. So JPA, you could have polymorphism in the database, and this was the entire trick. So if we got back something from a database, we got a link without knowing whether it is a fiber channel or an old bus or whatever, or just a cable. Yeah. And the methods were in the abstract class, and we just call compute, I don't know, latency, or compute the bandwidth, and it just worked magically because of object orientation. So we eliminated all the casting and all instance of.
Yeah.
So this was one. It was a perfect project. The problem was the project was about to cancel several times because I insisted of calling it a fat client. So the idea was, the objects were inside the UI, which was perfect. But back then, everyone wanted to have SOA and not before microservices. And it was actually not allowed to build fat clients, but it worked perfectly. So the client had direct connection to the database, and it was highly interactive. It was very easy to maintain. It worked well. Similar project was for something like German mail, and there was similar problem. So there was logistic units. They were connected with roads or links, and you could have a bicycle as transportation, or you can have a huge truck. And a truck couldn't, drive on bicycle roads and bike roads, and vice versa. Very similar problem to the we solved it exactly the same. Polymorphism in the database. We got objects back, and it worked beautifully because everything was in place. Now, having said that, all other projects didn't have such requirements. So I think if it's something to do with a network, object-oriented way of working is beautiful, given you have polymorphism in the data store. You know what I mean? So the factory in DOP, it was my data store, my entity manager. I got the right object back. I called the method, and it was done. And the last thing, which was beautiful, Nikolai, maybe it's too much, but the last thing, imagine we had simulations, right? We could say, what is the best possible solution to drive from Munich to Hamburg? And then all the roads were created behind the scenes in memory. Then we called commit, and everything was in the database. But this only worked if I had access to the objects, to the objects in memory. If you distribute the thing, forget about that, because you get a disconnected graph of objects, and if you send it to the server, no one knows what to do. Mm-hmm. So this was observation, so interesting, observation. And I said, okay, we can actually, and the entire idea was actually stolen from Smalltalk, I have to admit, because I work with Smalltalk developers, and after I chat with them, it's okay, this could work, and this worked well, and this was like my introduction why object-oriented working is very specific, specific cases is unbeatable. Having said that, in the last 10 years, I didn't had a single inheritance, I think. This is very, very rare to have on the server something with inheritance, or abstract class are rare. So it's a completely different story. So this was my introduction to the chat.
But that's good. That gives us a couple of concrete examples to talk about. So I think what you described there is a system that really, really wants to be in some way polymorphic, right? Like it has, for example, the first one that you talked about that has different channels and different nodes, mm-hmm. right? So there's a concept of a node, and there's a concept of a channel, but mm-hmm. there are different kinds of nodes and channels, and they all need to play ball with one another, I guess, presumably, or at least to some capacity, they need to work with one another. Mm-hmm. And I think object orientation makes a lot of sense there. So there is you have something like a node interface, probably you have a bunch of implementing classes, and then whatever you want to do in that business logic, you can reasonably add as methods to those nodes and edges.
Abstract classes. This is the thing. It has to be the abstract classes.
So
because if you put it to subclasses, there will be a trouble because you had to cast them, right? So it only worked if you exactly knew what you are doing with the abstract classes, with the supertypes.
Yeah, like I would have to know more specifics to understand that point exactly. So my experience over the years was that deep inheritance hierarchies. But you didn't say deep, right? You just said an abstract class and then potential implementation. Mm-hmm. So that's not terribly deep. So that's actually fine, I think. But I still, even that I tend to avoid. I usually have interfaces with implementations, and then I usually final classes, that is. And then I usually only operate on these. Sometimes there is a case where I notice like 5 different implementations use a lot of the same basic logic, and then I may create an abstract class. But I just create that abstract class, and I know that's not a good reason to use inheritance for code reuse. And I don't use that type publicly as a type. I don't mention it. I only mention the interface or the implementations, and that there happens to be like an abstract class. Sometimes it's just package visible actually. That happens to be an abstract class in the middle that I use to combine some shared logic. Is basically an implementation detail that is hidden from the outside. I had some very bad experiences with deep inheritance hierarchies of like specifically abstract classes, like 5 levels deep, and then come some concrete classes below that, and that always ended up terrible sooner or later.
This was a disease, I have to tell, because I work in enterprise projects, and back then, to show up as a developer, as a seasoned developer, you have at least 5 level deep hierarchy, and this was always the same, like entity. There was like ID able or something, so that the entity had an ID. So we have the first interface, and then we had an abstract entity, and this entity had get and setter for this, and then the next one. And I was like, okay, what are you doing here? Now this is like you would model a car. You could say we have a thing, a concept, something. Then we inherit from that this is something which could be, I don't know, which could move. You say, okay, we can do this, but we are not, describing the world. We should focus on our job, maybe. And you are absolutely right. But then we have 2 different aspects. One is called strategy. So I will go with interfaces, and this is stateless. Strategy would be, I have compression algorithm, and I have gzip, and I don't know, tar is not compression, but something archival, right? Gzip and let's say tar. And what in my project, what was the unique feature was that the behavior was depending on the state. This was the magic. So imagine, the bandwidth of the link was stored in a database. Mm-hmm. And depending on the state, we get different behavior. And this is why we had classes. It is impossible to do such a thing with interfaces. This was the magic. And if they change a parameter, in the database, the entire system behave differently, maybe, right? Because the simulation says, okay, if we get a highway limit in Germany to 120, every truck will go on the road bikes, right? So because it's faster, there is no limit there, for instance, right? So and this was the magic. In all other cases, I would say object-oriented behavior is object orientation is more nice to have. This is like choices, okay, do it or not. It's not like the entire discussion. Object orientations versus the inclusion. How it's called? There's a specific term for it that you, instead of inheriting, you can include classes or wrap them. This specific term.
Yeah, right. Composition over
composition, exactly. Composition over inheritance. This over, I would say, it depends on the feeling, right? It depends on the project, and this is too dogmatic, I would say, if you say something over. But okay, this was the observation. I think we have the strategy, we would like to encapsulate algorithm, which makes sense.
Yeah.
And the other thing is, this is the unique, which is try to explain, and it's a little bit hard to explain, is we have objects with behavior and state, and the state can have influence on the behavior, which was perfect in the two cases. But there were only, I think, 2 or 3 cases in all projects I did. So yeah.
But so another way, actually, one of my first blog posts that I wrote about that was about specifically such an inheritance hierarchy and how I fixed that with decorator pattern. So the issue there was, it was about, if I remember correctly, a swing listener that did some complex. So in the end, it was just a listener that listened to, I don't know, some kind of event.
Okay.
But it was like specifically some business logic.
Mm-hmm.
And this was a complex graphical user interface. And so depending on what was on screen, different things would happen. So it handled the click, but then it needed to do like one of a gazillion things. And as you said, it basically had the structure of sometimes we want to do this specific thing. So let's create an abstract implementation for that. And then sometimes we want to do another thing. So let's inherit from that class. So we get the one behavior, and then let's add our behavior in the middle there. And that kind of worked until the inevitable happened, and I needed to create an implementation that had like 3 out of those 5 things. But because they were caught in inheritance hierarchy,
operation unsupported.
I couldn't pick which one I wanted, right? Like if I inherited, I got all 5. And if I went like a level up, I lost like 2 of the ones I wanted anyway. So the solution for this was the decorator pattern, which should have been in the first place. So there are other better ways to share code than inheritance. That's why I said earlier that the abstract classes that I use occasionally for sharing implementation details, that's why I meant like it's not the best way to use inheritance. I think it's really a good idea to stick to inheritance, and I include interface inheritance in this, if you want to use the type as a type, not as a carrier for code. But as a type information that you want to operate on. And in that sense, for example, I would say that abstract list, which exists in the Java collections framework, is an okay implementation detail. It's a good scaffold if you want to implement your own list. But I think everybody can agree that it would be terrible to have abstract list running around in our code base as a type that we expect or that we return. It would work, right? ArrayList does implement abstract list, I think at least. So, but that's just an implementation helper type. It's not meant to be used as a type.
The name is terrible. Abstract already indicates it's a danger, right? And don't use it.
Right. So, and I really want to recommend to people, like in general, to only create types as none of these rules are ever strict. None of these rules are ever 100 or nothing. Mm-hmm. Like just try to push types that you don't intend to use as types out of your code base. And if you realize, like, I could fix this specific problem in another way than with this abstract class, but it would make everything much more complicated and harder to understand, sure, keep the abstract class. Like keep this implementation helper in there. It's fine. I'm just saying, try to make an effort not to do that. So every time you create a type, wonder, do I want to use it as a type? And if I don't, then don't create it. That also goes, by the way, for this habit of creating an interface for everything that has a single implementation.
And you don't never call it impl. So this is my only restriction.
Yeah, that's exactly the point. Like if you have the foo interface, let's call it foo, and then you have foo impl, you're already saying, I never want to use foo impl as a type. You always only want to use the interface.
Yeah.
And if you have it's different if you have like a library or a framework that people integrate with. But if you have total control over your code, just write a class. And if you then need the abstraction, tell your IDE, extract interface, it's all fine. As soon as you need a second implementation, that's all good. And again, this is not a strict rule. Sometimes there are situations where, like, for example, I've built something recently, although that is a library. So I was in that specific case where I wanted to use interfaces publicly only. But I knew that on my side, I only wanted to have like the one implementation at this point. I only did this as a level of defense against my future change to make sure that if I change the implementation radically later, I can have a separate, I can just implement the same interface. So I ended up with one interface and one implementing class. So there are obviously always exceptions to these rules, but I think it's still a good rule to try to limit the number of types. I want to go back to the object orientation you mentioned earlier.
Or I would just introduce my last thing and mention why it worked, and in modern system why it won't work at all. Why we need a little bit doping to make it work. So why it worked is because all the entities were managed. What this means, the state changes were tracked by the entity manager in all cases. So it means I could go, invoke a method on an abstract class and say, suggest another route. And the route was suggested, the graph was changed, and then I can say commit that it was in the database or roll back, it was rejected. Mm-hmm. The problem we get, if you would work via JSON with other systems, and I would do this, so then I say, suggest another route, and then I get a new object graph, which is completely detached from the data store. Mm-hmm. I don't know what changed. I don't have the before image and after image. So if I would send it back to the origin server, the server will have no idea what happened. You know what I mean?
Yeah.
So what I mean, this is, I didn't want to advertise, object-oriented behavior. I just said it worked well for attached entities. But in modern system, where you get data from JSON, ASCII, CSV, JDBC, not everything is transactional. You get objects per value or as copies. In my case, I could work with references. This was the huge difference, because references means, I kept the session Hibernate or JPA session open. We could modify all the objects, commit, everything was in the database. You cannot do this with JSON. So what I mean, this wouldn't work in modern microservice-like applications. So now why we need doping? Or we need to know my old way of working with instance of with new Java 21 plus features, right? So.
Yeah. But even in the example you already gave, I also want to open the door to why this, while it worked great apparently in the case that you had, why this might fall apart if you expand the system. So the system that you described had on those classes, on those types, had the logic, the business logic that you were interested in, right? Like tracking routes or communicating, calculating bandwidth, all of that. So that means that class had some logic in it that was bound to the domain of, let's say, routing, right? Yes. So did probably some graph search, I don't know, something like that. And that's cool. Now the issue arises when you say, okay, what I also want to do is I want to also paint this on a canvas. I want to have like a 2D presentation of these routes. And also I want to charge users for this. And I don't know, let's pick these three examples. So now we have routing, which is graph theory. We have painting, which is like a 2D canvas that you draw on, and then you have something that's related to a payment service, and like value-added taxes and different countries, and all of that stuff. If you would implement all three of those the way that you described, you would have a type that draws on a canvas, knows about graphs, and also knows about your payment systems. And that sounds terrible, right? You end up with a type that has wildly differing domains colliding in it, and that always leads to trouble. So I think what you described worked well because the main use case that you had for that system was really well mapped by that.
Exactly.
And then I feel like there was not many other requirements that existed around that. And if those start to rise, you end up with a situation that you don't want to put all that logic in those types. You want to put them outside of those types. You don't want to have compute route as a method on the node you want, or on the street or on the truck. You want to have a route planner that you pass the trucks and streets to.
Or compute fuel consumption. If you put other stuff there, maybe then if you have too much there, you're right. But the cool story is we had a canvas, actually, the UI. And this worked perfectly also for the reason, because if we set calculate simulation, right? So the graph changed, but the objects were bound to, this was Eclipse RCP. I didn't like that, but we had to use it. And you saw in real time how it changed in the UI. This was like magic, you couldn't do this back then over network. You will have these WebSockets, and it's just, everything was interactive. It was beautiful. But you're right, but this is in general true. If you have a class, a type, and it has to be cohesive, it means everything has to belong together. If you put another aspect, you have to refactor the thing, right? And back then, maybe we would create like functions like think about this were EGBs, were static like methods. So we will put the data transfer object and to create a data transfer object from the entity, or we would have go to the entity, give me a payment aspect or whatever, and we get a subset of this. You would use record for that right now, but you're right. But in general, we have to be cautious that how we're doing is we are creating classes, and they should make sense, and then we're adding more and more stuff. In one point of time, they don't make any sense because they are responsible for too much. So we split them, right? So this is and you have to do it. This is, the most important thing. You do it. If you don't do it, the system is not maintainable after a while because it does too much and no one understands why.
Right. Yeah. But that's absolutely right. But that's also a challenge, right? Like you want to add like what feels like a small-ish feature, but you realize if I add this small feature, I either start going down the route of building these types that contain way too much diverse logic, or I do the big refactoring now. But this was supposed to be a small feature, not a big refactoring of the entire business logic.
Yeah.
So so then there is an incentive to take the small step into the wrong direction.
Yeah.
And that just keeps repeating. And every time you do it, you basically make it harder to go onto the right path because it's always more code that you would need to refactor. It's basically technical debt. So you're going to this direction that initially maybe doesn't even, I think there's a level of experience there. I think a more experienced developer who has seen this fail in the past will notice it earlier. But I know damn sure I did the exact same thing early on in my first projects. Like, it was really crazy. I got out of university and people basically let me build my own system on my own, which was not a good idea for anybody. So I did these things too, right? Like, I didn't notice that I was taking steps that are definitely going the wrong way until years later I realized, oh yeah, I could have actually noticed it early on, but I just didn't have the, the experience or the I didn't know where this path was leading. It just looked like a good path. Anyway, so what I'm thinking is that to fix this, to pull this logic out of these, what you call data transfer object, out of these value objects that really just want to say, I'm a truck, this is my top speed, this is my acceleration, and I don't know what else, like my brake times and my, all that data that makes sense, right? The truck knows all of that. But then it's up to external systems to interpret that data for their specific need. And we have an object-oriented pattern for that. That's the visitor pattern. That's a way to have a route planner or, like the 2D visualization or the payment system that gets in a bunch of, basically, as I said earlier, a bunch of roads and trucks and demands for what to transport, and then does all of the calculation and gives you back a result. So you can feel about it like it's basically, it won't be in a complex system. It will have state and will be connected to databases and external services. It will do complex things, but you can collapse all of that in a simple enough system to it's a static function. It takes that input, roads and trucks, and it gives you back a route. So it's basically just a static method you call somewhere. You give it some data and you get back other data that represents the result. And how it does it internally, we don't care about that right now very much. And with the visitor pattern, you can do that, absolutely. And so this is, I worked one of the systems projects I worked, actually, I think it was one of the largest project. No, it was the largest project ever worked. Anyway, it was one of the largest projects I ever worked on. This used the visitor pattern extensively, because they had to. This is basically, I always describe this project as a mixture of Excel and Google Maps. And so it had to deal with a lot of different kinds of map information, and had to create a lot of different kinds of information. And the cross product of those was huge. And the way to do this is basically to have a visitor for each, right? So you'd say, okay, so I can deal with this kind of data and mapped information. And the other one would be like, okay, I can produce this kind of result. And so you would have a lot of visitors. And I remember from back then, I started there when I was a couple of years into my programming career. I found that challenging. First of all, it was a large code base in general, but the visitor pattern is hard to follow for beginners, I think even for experienced developers, because if you have some indirection there, you maybe have a registry where visitors get registered and then they get pulled out on demand. It becomes really hard to actually find the damn business logic. You have so much indirection and methods calling this that it's hard to see, like, where does it actually happen? What is actually being done? And so the use of visitor pattern there, I think, was definitely the right call. I'm afraid to imagine what this code base would have looked like without it, but it was still made it hard to follow.
Yeah, an old Java version was also terrible. You had something like accept usually, and you get
accept this.
Accept
you
this.
You always went somewhere. It was like accept this. I was like, no, but why? What happens now?
Then you get object or someone's generic interface, often without any methods. And if you are lucky, there was some method like get previous or whatever. And then you had to instance of and cast it and hope that this is the type, right? So, and this was like...
No, with the visitor pattern, you don't do instance of. With the visitor pattern, you push this into the compiler. So that's important, right? So
okay, this is what you are sophisticated. So in my, I was in projects, really. They built visitor patterns. Everyone was glad to say, wow, everything is decoupled. We have accept, and there is one super type. And internally, they say, okay, if instance of, then do this. I was like, all the types. So your was with compiler. I never saw that.
Okay. So let's go through how my version of the visitor pattern, well, the version that I saw.
Yeah,
I didn't come up with how that worked, and I think that's the official version too. Now let's try to do this from memory. I'm not going to open up Wikipedia on the site because their description of patterns always confuse me.
Yeah.
Okay, so my understanding is you have an interface for the things you want to visit. So let's say you want to visit different kind of graph nodes. You have different kind of nodes, triangle nodes and square nodes and circle nodes. So you create a node visitor interface. That has methods called visit,
yes,
but they do not have a method visit node. They have they have methods visit circle node, visit triangle node. Let's say we only have those two. Now, and then what you do, what the circle node does is it says, okay, when I'm being visited, I get a visitor passed in. The visitor interface gets passed to me, and I call on that visit this visit. So you pass yourself. And that works because the visitor interface has a visit method that takes a circle node. Now, if I start implementing my square node, what I will do is I will implement the node interface. The node interface has this method that accepts a visitor. And the only thing I can do on the visitor is called visit this. But there is no method on the on the visitor interface that accepts a square node. There's only methods for the triangle node and the circle node because the square node is new. So what I have to do is I have to go into... So I get a compile error. To fix that, to fix the visit this in the square node, I have to go to the visitor, to the node visitor, and give it a visit method that accepts the square node, the new kind of node. And now all implementations of the visitor interface have a compile error because none of them implement this new method. So what I've done here is I've added a new data type, and then through a sequence of compile errors, I arrived at all the operations that want to treat all kinds of nodes, because each of them has a compile error because it cannot handle the new kind of node, which is what I want to happen. I want to get compile errors in all of these operations so that I can go there and fix them. It's also, by the way, interesting that this means that when I add a new type, it's a little bit cumbersome because I have to go through all existing operations and update them.
Yeah.
But when I add a new operation, it's just one type that I just have to code top to bottom. So here in this case, in this structure, adding a new operation is simple because you only do it in one type. But adding a new type that I want to visit is a little bit more cumbersome because I have to go across all existing
behavior
operations.
is simple, right? Because you only have to extend the visit method for all types, but adding a new type, you will have to compile all visitors.
Right, and this is exactly the inverse of how inheritance works.
Yeah, exactly.
In inheritance, you add an operation, you have to go through all the existing types and expand them. But if you add a type, that's fairly simple. It's just one type just one class to write. So it's really cool to see how these two approaches handle different kinds of complexities differently well. So one of them is simpler. It's not a big difference. In the end, I have to write the same methods. The question is just where do they go? But it's still interesting to see how the one pattern makes it easier to do one thing, whereas the other pattern makes it easier to do the other thing. And I think that's how we should see most approaches to programming, most patterns, most programming paradigms, that they handle different kinds of complexity differently well. None of them is clearly better across the board. Most often you have to know, when is this one better than the other one? And so in the problem that I have, which of those is more likely to occur? So which solution do I pick? that's also something that, even the book that introduced patterns, they don't tell you this. This is something that is really hard, I think, to describe in general, because it depends so much on the problems that you're facing. This is something where, again, experience comes in and realizing, we've done this object-oriented in the past. It sucked. Let's do it functional this time, or the other way around.
I remember an anecdote. There was a Gang of Four Patterns book by Erich Gamma, and there was a conference, and someone said, "Okay, I implemented all your patterns," and Erich said, "Okay, you are crazy."
Like what? Like they found a code base to put them all in?
Yeah, you couldn't edit all the problems in one project. So my object-oriented thing is the exact opposite what you're talking about now. Now, the cool story is why it worked well was only because I didn't have to implement the visitor for change tracking.
Okay.
Because if you think about this, I have all the entities and I could change whatever I liked. And the entity manager did the visitor for me because he had to generate the SQL and I was done.
Yeah.
If this would be a distributed application, forget it. I would have to traverse the graph of object and see what changed and send it somehow back to server. This was the entire trick.
Yeah.
And my domain-driven world with the graphs is the exact opposite what you talk about now. But the outcome is very similar, I would say. As it's very similar thinking and this is also my observation in software engineering. If you have one pattern implemented correctly and you do the exact opposite, you get another pattern which is also working perfectly. So this is often the case, If you think about this,
interesting.
Yeah.
So you're saying like there's often a dual, like in math it's called, I think, a dual a problem or solution.
Oh, really? So, but if you think about this, there's a lot of such things which if you think, deep or proper, object-oriented way of working, or you say, okay, I'm just, do exactly opposite, and I don't care about object hierarchies, then you get the exact opposite. If it's a consequence, if there's a really, I would say, a proper implementation, it works surprisingly well.
So I don't recall right now where I picked the term dual up. I'm pretty sure it was during math studies. But the idea behind that is, and I have very murky understanding of that, so I can't really give a good definition. But the idea here is that there's often if you do math, like and I'm not talking about arithmetic, I'm talking about actual mathematics. You propose rules and then and definitions first you start with axioms and then some definitions and everything, and then certain things follow from that. And there's often a very basic flip that you can do. You say, okay, instead of doing this, let's do the opposite. And so if you have like a bunch of rules and you flip one of them, what you often end up with is a system that that also works. It also follows rules, but those rules have a tendency that in some place they're basically flipped because of the flipped axiom. And so I think you can think it's often like two sides of a coin. I think is also a good description. So you can, and that I think also that in abstract systems that happens that you end up in situations where if you would have made one decision differently in the past, you would have ended up with something that looks very different on the surface, but still has the same structure, just reversed in some places. And it's really interesting to spot this. I think it would be much more visible if we had, like, every time we take a decision in software programming, I mean, according to the many worlds theory, this is actually happening, like a world splits off and one team does the one solution and the other team does the other solution. And I think there are frequent cases where they would end up with equally valid solutions that just have this one property flipped. But then the question is, giving the future change of requirements, which one of those systems behaves better with those requirements? So we come back to what I said earlier, like they don't always handle the same kind of changes equally well.
Yeah.
But Adam, I have a question about etiquette on your podcast. I want to pour myself another cup of tea. Should I do that off mic or should I do it on mic?
We don't have etiquette so far, so we're introducing now. You can do with mic whatever you like, but be careful, with the power, not that we get a discharge, and we cannot discuss the doping anymore.
I'm still here. Yeah. Exactly. Let's go to doping.
And so the opposite was another thing which occurred recently is the Loom, right? So Project Loom.
No, we cannot go to Loom now.
No, but I was
last time we got to talk about dope and we didn't.
Yeah.
You cannot start another complex topic, Adam.
No, duality or dual thing.
Okay.
Just the thing as an example. Let's imagine I do with Loom, I use Quarkus, for instance, So I could actually buy in the cloud on the high load, very high load. I buy a single machine with lots of CPUs. I add Quarkus with Java source code on it, of course, with microprofile, and Loom. And every request is request scoped. It means every thread gets a request, right?
Mm-hmm.
And I can scale millions of threads on a single machine.
Granted that the rest of the business logic, has
sure.
not huge requirements, because if every business logic thread needs to create like 2 megabytes of memory, a million would probably still run out of memory.
And given that I need, heavy load, several 100,000 transactions per second, and I can save money. So, and now I revert that. I'll say, okay, the same cloud, the same code base. Instead of EC2, I go to AWS Lambda. And now every request is a process. Loom doesn't make sense anymore. So it's out of sync because I get only one thread per process. And in the source code, I don't have request scoped anymore. It doesn't make sense. There are no more requests. Everything is a singleton, is application scoped. So it is exactly opposite. Everything is different. It is optimized for high scalability and lower cost by idle. And the other one is, but from the code perspective, almost identical. But this is the exact opposite. But then we can stop with Loom.
That is very interesting. So basically what happened there is that I don't know how to say that. Let's call it multiplexing. So virtual threads mean you basically multiplex over the real threads that you have, right?
Exactly.
Let's say you have a 16-core machine. You will have 16 real threads. And then you have gazillion of however many you need virtual threads being multiplexed to these real threads in real time as they're needed. So this happens within the JVM.
Yes.
But what you described basically happened is that this specific piece of logic is pulled outside of the VM, outside of the container, into the, what's that called, the layer below that?
HTTP API gateway and Lambda runtime. The Lambda runtime is like the EJB container back then. It's very similar, actually. It's identical to application servers from conceptual.
Yeah.
And
I think that, for example, is interesting, right? Because you would think that this would be, when I tell you, look, I'm giving you 2 different ways to write an application. Either everything, the platform handles the threat management and you just write for one request, or you have to make sure that everything, like this multiplexing on threads, happens within your application. You would think, oh wow, that sounds like a wildly different challenges, and that sounds like this code base would be very different. And in the past, you were right. Like if you would have to write a reactive stream-based code base because you needed that throughput, and reactive streams were the only way to get there, you would have a radically different code base. They would have the same business logic, but they would be structured in a wildly different way, because one of them is all reactive and the other one is just like, hey, I have this one request I need to handle. And now virtual threads got you to the point where, no, the code bases now are basically the same. It's just like, okay, I'll just do blocking stuff. I don't care about anything. Oh, that's interesting.
The thing, I never used reactive programming because it was, for me, it was unusable, actually. So maybe a special case if you know exactly what you're running. But the interesting part, the one architecture is called serverless, and the other one is serviceful. So even the names are different. And what we pick depends on the costs, on usage profile. It's just cost optimization. But this is exactly opposite. And lots of such examples. But and this one, why I like the doping, I listened to your session in CERN, and that is okay. This is, and I did it now all the time, for a very specific case for NoSQL databases where doping works perfectly. And at the end, I get similar behavior to my object graph, from 20 years ago with the JPA. I don't have JPA anymore. The database in the cloud, I get JSON, as an object, but I can use doping, data-oriented programming for similar behavior what I get back then, because the entire environment changed. I don't have, attached objects anymore. I get object per value. The type is encoded in the value, not in the subclass. This is exactly opposite, right? So the type was in the hierarchy, and now the type is the object itself. Because in my database right now, every row can be a different type. It was unthinkable in the SQL databases. Every row was the same type with the type discriminator inside. So even this is almost an opposite. So okay, but
let's talk about DOP.
Yeah, DOP. We should start at least.
Yes, exactly. Okay, so first of all, this is the term that we've been using here. let's pretend it was a term. So what we're referencing here is the concept of data-oriented programming, and we'll keep talking about this for the next couple minutes. I take it, but just for fun, let's call the dope that Adam is having here. That's the data-oriented programming excitement.
Yeah,
that's the dope that he's taking, that he's making us,
which is legal in Germany, or
which is now legal in Germany. Exactly, you can now get high on your data-oriented programming. But yeah, so let's talk about data-oriented programming. So I don't know much about the history of the term, but I looked it up a little bit, and it's interesting that this is, first of all, this is definitely not new, right? I'm not saying this is like the new hot thing under the sun. First of all, data-oriented programming is similar to functional programming, to the point where I would say it's more like a specific way to do functional programming. Don't be scared, though. It works now in Java in a way that is very well, like it feels very natural in Java. So don't think like complex functions and monads and all of that stuff that maybe scared you away from functional programming. But I just want to say, like, this is, I just want to make clear for those who know functional programming, they're not here to plant a flag and say, this is something radically new, listen to how smart I am. That's the first part. The second part is, the term data-oriented programming in Java has been, or let's say Java and some other programming languages that haven't used it so long, so for example, JavaScript, has emerged a little bit over the last couple of years. In JavaScript, the idea is everything, so that's generally the idea about data-oriented programming. You have the data that just represents a specific state, and you pass that to functions that then operate that based on what data they see. That's why it's so functional. I'm going to go into detail on that later, but what I want to say here is that a way to do this in JavaScript is every object is basically just a map from string to something else. So either string to value or string to another object, which would be another map from string to object. And there's at least one person out there who whose name I forgot though, who went on a few podcasts and also wrote a book about this, and he proposes data-oriented programming in Java. And I haven't read the book. I listened to a podcast though a while back. So if I misrepresent his position here, I'm sorry. My understanding is though that he basically proposes, let's keep using maps. I'm not sure whether he proposed to use map as a raw type, or whether he wants to go with map from string to object. But the point is basically says, no, we can do this in Java too. We don't need like the whole object is blah, blah, blah. No, we just get everything as a map from strings to either a value or a new map. And, if you just think about the data that an object stores, you can, actually, I wrote this because I needed this for the project. You can map from a record easily. I mean, also from an object, but it makes more sense for a record. You can map a record to exactly that, to a map from string, that would be the component names, to, again, either another map or, specific values, path, string, double, float, whatever you want to handle. And so his proposal is, no, let's do that. And this, to me personally, feels wild. It means like throwing all the type safety that Java can give you out the window and be like, no, we just do it like JavaScript because it works so great there. So yeah, I don't like that. So I follow the data-oriented programming model that Brian Getz proposed. By this point, I think maybe 2 years back already, in an article on InfoQ, where he described what data-oriented programming in Java looks like. And
Nikolai, this with map, it is the same as JSON, right? Because JSON is a map, and the added value in JSON is that the value is somehow typed. At least we know what JSON types are. This could be, this number and string, and could be a array or another JSON object, and this could work. I remember also a very long time ago, we built a remote procedure call, which was not based on RMI. And I think, used Jakarta Commons beans back then. With the beans, you could deserialize. It just not destructured. It gave you very easily, via reflection on the entire structure of the object. So we created more or less hash maps and could send the hash maps back and forth. It was slow, but it worked well. I mean, the cool story was we were always compatible, right? The idea was, if an object got a new field, we could deal with it because the map arrived and we could map it. So this works. And with records and components would work perfectly, actually, because in reflection you can say, hey, record, give me your components, and you can map them to hash map.
Yes. So like the perfectly part, it has an asterisk though. So the very interesting thing about seeing this object graph as basically untyped, map from string to whatever, has the huge advantage that you only need to care about the part that you actually care about. So you want to change like 3 levels deep, you want to read those 2 fields, and then you want to replace some of those values. You can do that and leave the entire rest of the map untouched. If your system doesn't need to care about the rest of this huge object, JSON, the object that it gets, it just needs to go into the specific part of the path, fiddle a little bit with the numbers there, and then send it on its way. And it wants to be intentionally transparent. So everything else that comes in or goes out, it's like, no, I don't need to touch this. I don't want to know about this. Everything else just passes through the system. That is something where if you map it to types in Java, you actually get a little bit into trouble, right? Because in Java, if you add a new field to the JSON, it either gets lost on the transformation to an object or to a record, or you have to add it to the record. I'm not sure whether that feature exists, but what I think would be nice would be for JSON libraries to have a feature which is something called like a remainder or something, where you can say, these 3 components of the record, please map them to entries in the JSON object, but everything else, all the other property attributes. No, wait. What is it? Attributes or properties in JSON? Whatever.
Attributes.
One of those. I think attributes.
Yeah.
Doesn't matter. One of those. All the other ones that I get, don't parse them. Just put them into this map. And when I give you this object back, just take the map and flatten it into the object.
Yeah,
I think that would be kind of cool, because then you have you have much more leeway into modeling just the part of the system that you actually care about, and be more lenient with everything else, which some systems definitely benefit from. So if you think about something that handles
almost
events,
something like this, because you have a key, and if the value is a JSON object, then you know that you can deal with it, right? So as a JSON object, otherwise it's just a normal attribute.
So you're saying, like, if I use Jackson, for example, and I give one of the components in my record the type JSON object, it will just pass in the... Okay, that's good. That's much of the way there, but it's not flattened, right? It's just the attribute still exists.
It is, if you open it in Visual Studio Code, you will see nice object hierarchy. So you can format. It is not flattened. It is not like JSON serialized in string. It is more like JSON object, right? So I use JSONB and Jackson indirectly, so usually JSONB, and I can have nested JSON objects with arrays. And what I get, if I look at this, it looks like a proper JSON. So I could send it to JavaScript, and you see the object. So this is working well, but we go too far to object serialization.
Okay, right. Yes.
But I know what you wanted to say, and I just wanted also to promote a bit the component from record, where you could easily serialize a record to JSON by yourself, just with reflection, if you like to, on a weekend, not in projects, but as additional excitement, I would say.
Yeah, so that's actually something, as I said earlier, that I needed for a project. I needed to transform records, one kind of record into another kind of record.
Which is
maybe. Great intermediate representation is just a map to take a record. By the way, if we say record component, just for those of you who don't know, we said it a bunch of times now. So if you define a record, you say record, then the name of the record, and then parenthesis, your list. Let's say string path. No, actually, okay, path should be a path. So let's say path file, comma, integer count, something like that, right? You're counting files apparently. That goes into parenthesis. I'm pointing at the camera with my hands here, which makes no sense. So you get round parenthesis behind the record name, and the things you put there are called components. And what you get is final fields for them. You get a constructor that accepts them as arguments. You get the accessor methods. You get equals and hash code. All of those built on these components. So that's what we meant by record components. And the cool thing is, if you know that you have a record class in hand, you can ask by reflection. If you have a class, you can ask, "Are you a record?" And if it is, you could ask it, "Give me your record components," and you get back an array of the type record component array. And you can ask each component, "What type are you? What name do you have?" I think that's the core information I use. There's probably more in there. And that means that you can very easily say, "Are you a record?" "Yes." "Give me your components." "Great." Now I map from each name, which is a string, to the value that you have, and boom, you have a map. And you can go the other way around just as easily. You have a map, you get a type of record, and then just say, "Okay, so this is a record type. Cool. Let me just iterate over its components. And for each component that I find, let's look into the map where I have a value. whether the types are either the same types or I can force it, right? So you can always take a string and turn it into a path, or you can take a path and turn it into a string. There's a function, there's a by function there, a function that goes, actually no, by function is the wrong term because of the way Java uses it. There's functions going both ways here.
Duality.
Yeah, exactly. And so that's why that's a nice thing to do, and you can do that in your spare time and tinker a bit with that. But yeah, I think if you use it in a project, you should look whether there's something like maybe MapStruct or something else that already does this, because I'm sure there are corner cases to consider that I didn't. So it's always good, I think, with that kind of logic to first check, does somebody else already do this? For example, if you want to turn your records into JSON, that's cool and nice to do yourself, but probably Jax is going to do a better job, considering like, oh, maybe we need to escape the quotation marks in the string and all that kind of stuff, right? So there's always edge cases where it's good to use external libraries for production code. Okay, so let's talk about data-oriented. Let's go back to data-oriented.
Okay.
So now we have, so let's not use bags of maps. Let's not use like a map from string to object to model the data that we operate on. Instead, let's use records. And what we just described is, since you can use both of these, basically they represent similar information, but what you get with a record is, of course, type safety, right? It gives you type safety. It gives you a constructor that you can use to make sure that you only get valid states.
And less code. I mean, even with map to construct something is way too much code. I would say this is not convenient. So if you use record, even nested records are easier to construct with map of maps.
Yes, yeah, you're right.
Yeah,
and just the type safety is for me as a Java developer. That's just like that's the only argument I need. Because like I've programmed in JavaScript every now and then. I do program in JavaScript every now and then, and I always have the problem that when I come up to an existing project, it's hard for me. Even my own project, by the way, that I didn't work on for a couple of weeks, I have a hard time tracking what goes where. Because what I really like is that if I get an input into a Java method, I can just go to the parameter and say, give me the type information.
Yeah.
Like, oh, okay, so this has a name, it is this. Oh, yeah, that makes sense. I can reconstruct the business logic. I can see what I need to return. And whenever I did regular JavaScript, not TypeScript, I was so confounded by, what is it? I get something that's called user. I mean, that's cool. It's probably a user then, I hope. Or maybe it's just a method a parameter that didn't get renamed. But what does it do? What does it have? I don't know.
The best error in JavaScript is undefined was not defined. This is my favorite. and there's a trick. If you use Visual Studio Code and you have your own objects, you can use JS-doc, which looks like Java-doc. If you put it on the methods, you get almost like Java type safety. Oh, it's type safety. Visual Studio Code will complain at least, right? So there's no type safety per se. It is.
Yeah. But you get like hints and stuff.
You get 60% of Java, I would say, right? So if you
yeah. And so now we use records, right? So we just settled on these maps of data for just bags of maps for our data isn't great. Let's use records. So that's one cornerstone of data-oriented programming. Use Java's strong typing system to model the data, but don't just model the data. Mm-hmm. Don't put the business logic on there. The core tenet here is model the data, the whole data, and nothing but the data. Mm-hmm. And so if you have, for example, route planning, and you have something like different kind of vehicles, you create a truck record that contains exactly the fields that your truck JSON or your truck CSV or whatever has. Exactly. Don't do anything fancy there. Just map it as simply as possible to have an exact representation of the data. Validate at the boundary. So in the constructor, or if that gets too complex, maybe in a static factory method, do make sure that only trucks get created that are actually valid trucks, right? So if it has a negative maximum speed, that's wrong.
But we could do this in the compact constructor in records, right?
Yes, absolutely. Like in a record, you have this ability to have a compact constructor which just takes all of the components as arguments, and then you just write the validation code. And once your code executed, after that it will assign to fields. Exactly. So you really need to put in that code block only the minimum amount of code that does the actual validation. And that is not only good because less code, makes stuff a little bit easier to write, but also means that when I read this, I only see the relevant part. I don't see the blah blah of assigning stuff to fields. I just see, okay, there's two lines here that both validate something, like something isn't null, or the speed is positive, or whatever, the string isn't blank, stuff like that. The path to the file actually exists, things like that. So that's really helpful. So that's the other one. First one was model the data, the whole data, nothing but the data. We're not ready with that one yet, but we went to validate at the boundaries, which is constructors or otherwhere where you construct these things. Make sure that only valid instances get created. The third one is data is immutable. And the idea behind data being immutable is that that has advantages in multi-threading, for example. It also means that when you get elements out of a CSV file and you want to write new values to a CSV file, you also get actually new instances of this type, because the data instances themselves are immutable. That gives you a trigger to realize, oh wait, like how do I write this back? But the biggest and most indirect benefit of this is immutability makes a bunch of things much easier to reason about. Like, you don't see this until you've used it a bunch, but there's a whole category of problems that you don't have to care about anymore. It comes with other downsides. Like, it's sometimes a little bit cumbersome to be like, okay, now I need a copy of this record that has this one field changed. Would be so much nicer to just change the field directly. But it is really helpful because it makes a lot of problems go away and makes a lot of causes for issues, which is things changing, very obvious. You can't just call a setter and then the value changes and then, that everybody else has to realize that this might have implications on, for example, how you store this. No,
and from data-oriented perspective, it also means for me data flow. And if you cannot change the record, you are forced to create a copy or whatever and send it back. Because
that's what I mean. Like, every time you call new, you notice, this will not, whatever needs to happen with this newly created instance will not happen on its own. Exactly. I need to think about where to put this. Whereas when you have a setter, it's easier to dilute yourself into, no, I'm pretty sure the right thing will happen.
And you see, this is exactly the opposite of my project, because in my world, the object were attached. So copy will kill us. We had to change. We had to invoke set on the object, and then it was synced with the database. In this particular case, because records are not attached at all, they are just copies of data, they have to be immutable so that you can send them back, right? Because otherwise you will modify them, nothing will happen. So you just change the state, and it's like a corrupt state because it doesn't reflect the origin state it was before.
Yeah, and that's good, right? So the fact that you need to create a new instance triggers, as you said, like this consideration of where does this data need to go to update. Okay, so we have... that's why immutability is interesting. And a record has final fields, so you cannot reassign the fields. But of course, it's still Java. This is not magic. If you have as a component a list and you pass in an array list, then everybody who calls the accessor for that list will get a mutable list. So they could still say, okay, so this truck has a list of destinations. Get that list of destinations. I cannot assign a new list, but I can just clear the existing list. Not good. So you probably, and this is one of those things where I want to say, there are reasons to make exceptions. Sometimes during your process, you still want to have a mutable state because you're still gathering state. You're still picking up stuff, right? So let's say you are reading from a CSV file, and there is a phase where, yes, you have all the trucks loaded, but every truck has a list of destinations, but you're still parsing that list of destinations. You're still putting that together. So you're in a situation where the list of destinations must still be mutable. But generally speaking, don't do that. Generally speaking, try to make those that stuff deeply immutable. So if you have a list of destinations, create a copy. Say list.copyof destinations, and what you get back is an immutable copy of that list. And then if somebody calls on the truck destinations calls clear, they will get at least a runtime exception. I know it would be nice to have a type that expresses that it's going to be immutable, so you don't even see that method. We can maybe have this conversation another time, but that ship has sailed. Actually, you know what? We should do this, Adam. We should have a podcast at some point where we talk about all the things that would be nice to have in Java and why we can't have them. So make a mental note.
Okay.
We can have a talk about that, so we can make people disappointed a whole lot in that podcast.
Okay. But I like Java a lot. It will be hard, but I have to think what is missing. Okay.
Yeah. So right. So work to make these things immutable. We had validated the boundaries. We made illegal states unrepresentable. What else do we do to model the data? So far we just use records, but there's often, and here we go back to the nodes and edges example, for example, from earlier, but even with vehicles, we see the same thing. Often you have alternatives. You're often in a situation where you say, let's say, for example, every truck has a driver. And because we started writing this program in the 90s, obviously this driver is a human. But now it's 2024. We're preparing for the future. Maybe the driver is actually a bot, an AI, right? Or maybe it's a remote driver somewhere. So what we need is
a remote driver would be cool, actually. So this would be cool.
Those exist actually. I heard that there's a valet service in New York, I think that is, that parks your highly tuned BMWs, but it's not a physical driver. They remotely take over control over the car.
It's a great job for a teenager, actually, right?
Oh yeah, great. Yeah. Here's my very expensive BMW. Please park it.
This is better than a game. This is actually a video game, a real one. 3D.
Yeah, exactly. Don't tell the kids that they switch from GTA 5 to parking the cars. Okay, so what we do now is let's say we have a human driver record, and we have a remote driver record, and we have an AI driver record. These are very different, right? They're very different fields and stuff. Don't try to generalize this. Don't try to have one driver type that has like a driver type enum and that then figures out which one is which. No. You have these 2 different kinds. So use a type for each of them, but then create an interface driver, which they all implement, and make it sealed. Because we only can have these 3 types of drivers at the moment. Make the driver interface sealed, and then the truck has a driver component. And if you ever want to deal with the specifics of the driver, then you would need to, we're going to come to that in a second, do the data-oriented programming approach to how to handle those drivers. Now, you can, of course, put properties or values or functionality that all drivers have in common on the interface driver. That's not a problem, right? So, for example, let's say all drivers have an ID, right? Because there's a system there that tracks the drivers, like for whatever reason. Every driver has an ID. So sure, give the interface an ID method. But do not give all drivers, the driver interface, a payment method. Because you don't pay the AI, right? It's already bought. It's already in a system. It doesn't have a need for this. So yes, you could just provide no implementation, but don't do that. Don't fake a generality that is not there. Lean into the specificity. No, a human driver gets paid, a remote driver gets paid, AI doesn't get paid. So the payment method goes onto these 2 types and not on the interface.
This is another, how to call it, duality or dual behavior, because in my world, all the methods had to be in the abstract class. Otherwise, they would be not usable. So in the subclasses was just the implementation was different, So the implementation was in subclasses. The contract was in the abstract class. In doping, we have the type is just a type to pass it to a method later, and there should be not a lot of methods. And if they are, it's just some convenient stuff. And and all the thing which matters is in the records. And this is exactly the opposite, because it's really interesting if you consider both. By the way, completely different question. Not different question. It is somehow related to data-oriented programming. What I'm missing actually with record is able to destruct them without instance of. You don't miss it. You know what I mean? Because if you have instance of or switch, right, you get the record in and you extracting the variables. And I thought it would be nice to have a block, because I know that I already have just the one. But I would like to destruct it very easily to variables without calling, you know what I mean?
Yes. So there's hope for a fix for this in the future. It's called deconstruction assignment, where you can do something like, for example, in JavaScript, where you can say, I get an object and I want to destructure it into just the 2 values that I need. That is probably going to come. There's a tweet by Brian Getz where he promises it, but I don't want to lean onto that too hard. But yeah, so it's on the roadmap.
But you are also missing this, right? But from time to time you say, okay, I have it. And I really would like just to have to know two variables out of 5. I already know this is my record. There's no instance of required. And the only way to achieve it, you need an instance of block.
And the instance of block is also a problem because it forces you into an if. So that means if you want to return something from this function, you have to put something into else.
Yeah.
So that's kind of weird.
Okay.
So the reason why the tour went through instance of is not to make instance, like actually I would recommend to use instance of very rarely still.
Yeah.
It's not to tell people instance of is great now. It's just the obvious place to start exploring this because instance of already does type checks. And if it already does type checks, it's a good place for this conditional.
Yeah.
Well, if it is of that type, give me that variable. Yeah. If it's of that type, destructure it into the variables. But it's not going to stop there. It's not like now we use instance of everywhere. It's just, it's an evolution.
Yeah,
it's an evolving situation.
So I'm glad that you're also missing that. So
yeah. Also, something I miss terribly is with expressions. If we have the time at the end, remind me, and I will talk about that. So let's go back. So we have now these types, and let's go back to payment, right? So I said yes, there could potentially be like a pay method on the record or on the human driver, on the remote driver. But actually, to a degree, I want to take that back, because a pay method is something that probably needs to change something in some remote system, right? You cannot just call pay on a record instance and expect it to do something meaningful without reaching out to other systems.
Yes.
Its own state is immutable, so it cannot even set the I was paid flag to true. That doesn't even work. It definitely should not accept a payment system as an argument, and then go to the payment system and talk to it itself.
Mm-hmm.
So what you would do in data-oriented programming is, let's say it's time to pay all the truck drivers. You would get, let's say, a list of trucks, right? And then you would start, okay, let's turn the list, probably turn it into a stream. Let's do a map and take the driver out of the trucks. And now we have just a stream of drivers. And this is where the interesting bit starts. Now what you would do is you'd say, okay, in the payment system, this is where I'm writing my code right now. I'm in the payment system. I'm streaming over these drivers. And then I write a method that is called pay and gets as a parameter the driver. Let's switch over that driver. And in case it's a human driver, do X. In case it's a remote driver, do Y. In case it's an AI driver, probably do nothing. And this is where otherwise you might have had a visitor. What you're doing here is you're saying, depending on the type, I want to treat things differently. Mm-hmm. This feels weird to Java developers. For the longest time, we've let the compiler do that with inheritance, right? This dynamic dispatch, which means depending on the type, I want to call a specific method. We've had that done. We delegate this to the compiler. If I call add on a list, I know that the compiler will figure out whether to call linked list add or array list.add. And that's perfectly fine. So wait, let me turn off notifications here. Okay. So that's perfectly fine in most cases. But what it requires is, it requires us to add the method onto the interface as a contract. And again, maybe we don't want that. So the other way to do dynamic dispatch is not by adding methods to interface and then the compiler, the runtime do it, not the compiler actually. No, the way to do that is to put it explicitly into our code and say, okay, now I'm switching over the type, and depending on the type, I'm going to do X, Y, Z. And we don't do this willy-nilly. We're not going to do this everywhere. We're not going to create a new kind of collection interface where you need to switch over the type every time you want to add an element. You only do this in situations where you do not want to put the method onto the type. And data-oriented programming / function programming is a programming style that says, let's not do this. So that's why this goes together. That's why this you need both of these things to make it really work. You need this approach where you say, I don't want to put all the methods onto the type. And you need this kind of easy to achieve behavior, because this is also safe. That's very important. The other reason why we didn't want to do this, because A, dynamic dispatch was already done by the runtime, so why would we want to do this? But B, the series of instance of checks, and I'm pretty sure you noticed that in the project, is terribly unsafe. You add a new node. I mean, I don't mean insecure, by the way. I just mean like it's not safe for future changes. Mm-hmm. You add a new kind of node or new kind of connection, and now everywhere code starts failing because it doesn't know about this new type.
Yeah.
Surely, back in the days, the project you described had like 100% test coverage, so all was good. Yeah. You just ran that. You couldn't see this, but Adam was nodding very ironically.
What I did in the project, where I remember, is like we should at least have a test that we show that we are able to serialize and deserialize the entity from the database. That I was, otherwise I will quit immediately. So at least try to save the entity to the database. And then we had lots of unit tests. The cool story is in the object.
Oh, so you did? Okay.
So because the cool story was the entities you could just construct in memory, the entire road, and then just call the method and see what happens. So this from the testability worked well. From the integration test, they were a little bit lazy, but from the unit test it worked well. But if we had problems, always with integration.
Right. So, but you did have unit tests.
Yeah, I had a unit test. Right? This project was very good. Without unit tests, it wouldn't be doable. But now, what you always saying that the Java developers are not used to work in this way, and I can tell you they absolutely are. And the reason being is we already covered, the developers who like deep inheritance, And this deep inheritance in enterprise projects always happens on persistence. And now we get, very strict architects, and strict is a very positive expression. I wanted to say something different. So, and the strict architects say, okay, for every entity, you have to create a data transfer object. And now you have a hierarchy of data transfer objects, which without any behavior, and they are detached. And the only thing, to work with is a series of instance of.
Oh, wow. Okay.
So, and this is what causes a lot of problems in enterprise projects, because you get a data transfer objects back, which are detached from entities. So this is the worst of both worlds. And now you have a series of instance of to find out what happens. And this was one layer. There are even stricter architects who say, okay, no, there's data transfer object from the entity cannot be exposed to the client. So they are mapping at the boundary level this data transfer object to another data transfer object, which was actually meant to be sent to the client. And now we have two levels of with lots of instance of, and this is absolutely unmaintainable. So I would say we are already there. And
it makes me sad a bit, but yeah, I see your point.
Yeah, decoupling. If you go to enterprise projects, you say, okay, then come a guy with a suit and say, we have to decouple, and they say yes, and they decouple, and cost millions of euros without any additional value. So, and another thing what we get is where we already, all of us do data-oriented programming, is because if we call out a system, we get JSON back, right? And with the JSON, we have to do something. So we cannot just map it to JPA entity, because, this is not JPA entity. The best we can do, use Jackson or whatever, right? To get, the class. And then we have to call our system with this. So if this, sometimes it's even generated from OpenAPI. So there's an OpenAPI description. We get a Java object which is generated. The only thing we can do is to use it somehow and destructure it, extract the relevant data. It doesn't even have it. It must not be type safe, because type safe would mean if the other system adds an attribute, it will break our system. So what we have to do is to extract as soon as possible data which matters to us, forget the other data, and then where data-oriented programming kicks in, because this is the beauty. We get the record, we can dispatch on the record, we pick data which are interested in, forget the other data, and then we call our payment system, for instance, right?
Yeah. So not every series of instance objects, by the way, just
switch.
Qualifies.
Switch, of course.
Yeah, but in the past, qualifies as data-oriented program. I think it's a couple of things that need to come together. But the reason why the switch is safe, as opposed to the series of instance objects, is that the problem with the instance objects, of course, is if you add a new type, nothing like the behavior of the code might be negatively impacted, but nothing you can find at compile time. Now, if you have good test coverage, you can find out the missing instance objects. You can find, I added a new type. Now I need to add the instance of here and there.
The unit has become brittle as well, right? Because you have to update all the unit tests as well.
Yeah, but ideally you don't have to update the test, just the code that it tests, right? But yeah, you probably have to add tests for the new types. Exactly. But that would be important anyway, I guess, because they still have different business logic. But the point is, if you have good test coverage, at least you find those places during testing. If you add the right tests everywhere, right? So let's say you have 5 subsystems that do these instance objects, and you only add new tests for the new type for 4 of them. Then the 5th one won't have a test with the new type. You won't have a failing test then. And then
you will have to add 20 tests, because this happens in 4 places. It's not like you have one. The different aspects is usually one dispatch, one aspect, right? One has payment system has to dispatch, and the validation system has to dispatch. It was terrible in the past.
Yeah, but most of that, I think most of that still remains. Like if you add a new type that goes to 5 operations, you still need to make sure that in all of these operations, the right thing happens. So you don't have to do the test. So in the past, you would have to do the test to even find out where the code fails.
Yeah, exactly.
Now you would write the test to make sure it's the right business logic. You still have to write the test. But the important point is now that you get compile errors. That's like the critical difference. Like with the visitor pattern, you add a new type, and all the switches that go over, human driver, remote driver, and AI will now notice you added a 4th type. And by adding first of all, if you add a 4th kind of driver, you get a compile error immediately on the 4th type, because it says, no, you said the driver can only have these 3 implementations. So you go to the driver interface, you add the 4th type, and now all of those switches will fail. All the switches that switched over those other former 3 types will now not have a case for the 4th type, but switch wants to be exhaustive. Exhaustive means it covers all types. It wants to be covering all cases, even in situations where, strictly speaking, it wouldn't have to. So meaning, if you switch as a statement and you just don't have a case for the 4th type, you could just say it just does nothing for that case, right? That makes perfect sense. That's how switching over an enum works nowadays. But that would be terrible, because then adding a fourth type would mean all the switch expressions break now, but all the switch statements still work, which is horrible.
Yeah.
So what you get instead is, if you switch over a complex type, meaning not an enum, not a string, you need to be exhaustive whether it's an expression or not. And then you get all of those compile errors, which is good. So you go into all of these cases, you add your fourth type, you notice, oh, I need to test for this, I need to test for that, right? The compiler leads you where you need to go. And that is very, very important for this, because otherwise this would be really hard to maintain in larger systems. And that's why don't do type checks makes sense in a situation where type checks make code unmaintainable. But if you have a sealed interface, and if you switch over a sealed interface, and if you then avoid the default branch, we can quickly recap what we said about that last time. In that situation, adding a new type will get you a compile error. That's all the maintainability and safety you can reasonably expect. That's what would happen with the visitor pattern. That's what would happen if you used inheritance. Adding new stuff gets compile errors, you fix those. So that's great. And that's why this becomes feasible now, and it's not less safe or secure or whatever. Well, secure anyway, but not less safe, not less maintainable than the regular object-oriented approach. So that's why this is so important. That's why the sealed interfaces are so important.
And I would say, if you're dealing with external systems, provide JSON, some data which is not necessarily directly mapped to an object, I think the data-oriented programming is just a reasonable thing to do, right? It's not like this is the decision already made, because I could try, to map this external data to a beautiful Java object, but this is almost mission impossible, because the chances are very high that the external system is not pretty, right? So the data that gives us is not this what we would like to have. And with the first switch expression, we can create as converter even. We can we can use like the boundary to external system. So we expect not nice objects and create nicer objects, and then we are in our domain. And then it doesn't make any sense, to create objects, so we can keep doing records, which are objects behind the scenes anyway.
Yeah.
But the records, the record instances are passed to the next layer, and then we are in our systems. I would say data-oriented programming is even useful to have like a pragmatic decoupling from external world.
Yeah. So like if you look at a high enough level, then basically every service is a function, right?
Yeah.
You pass something in, you
Yeah.
get something back.
Yeah.
And you could argue, well, it has a side effect because it writes to a database, so it's not pure, but you can actually just say the change that goes out to the database is part of the result of the function. You
Yeah.
call it with some JSON, and as a result, you get some JSON, but also you get a request to the database. So you could, and then as input, you also, so you can make it look more functional than.
But it doesn't have to,
otherwise
right? The arguing whether this is pure or not, it has to work. I would say it has to be testable, has to work.
Yeah, right.
Yeah.
But what I'm saying is like you can already at a high enough level, you can already see like you have a node, in goes JSON, and some data from database, out goes JSON, and some data to the database. That's what a function does. And now the question is, if you model that system, does that approach also work internally? And I think there are good cases to be made when you have like heavily stateful applications. Desktop applications are a great example for this, that are just basically building up an object graph and then waiting for the user to interact. The user does something, and then you change this whole thing. And then, so that's something that I think it's always possible. Functional programming can be used for this, but I think that would be more challenging. But I think web services, specifically small ones, really narrow down on this functional approach of I give you this, you give me that back. And it's like this back and forth. And so I think this approach also makes sense internally. And as you just described, the external system sends something in. And what you could do with records then is you could just map this data one-to-one. Just say, okay, this is the JSON we get. We're going to create the records that are exactly that. And we just already talked about earlier about how do you handle changing fields. So there's something that could be done there. But the overall approach is, I don't care about what I need. I care about what the world gives me. That's the first layer. And then maybe the next layer would be, but what do I need? How can I recombine the information that the JSON gives me into something that makes sense? And as you just said, this is just a transformation. This is a function. Taking these records, first is taking the JSON, creating the records one-to-one. That's a function. Taking the records and then remodeling that is the next one. At some point comes the business logic. And I think many, specifically smaller services, but also something like batch services that you write or something, can be viewed through this lens of it's just data flowing through my system. And if you have this view of its data flowing through your system, the data-oriented approach just jumps right at you. Like you don't even have to think about, but I want to use monads because I was in a Scala talk 20 years ago. No, you can just like this. this is why the functional programming, why Scala, not to say something bad about that at all. That's where this came from, right? It came from this understanding that that's essentially what these services are doing. They're taking in data, they're modeling.
By the way, Scala needs doping as well, because the compilation takes forever, right? So they have to do something.
They do have DOP, though. They have the data-oriented programming, but yes, maybe they need doping.
Yeah,
I can
exactly.
tell. I'm not sure. I'm not doing that a lot. So, but the point is that, sorry for the interruption, that you can see what the system does as flowing data through it. And I think this is where you should start with data-oriented programming if you're curious. So if you are curious with it, I do not recommend to take a big service and say, like, okay, we throw it all out. We're not doing data-oriented programming because of the podcast with Adam Bean or Nikolai. That sounds like a terrible idea. And I think most listeners, actually probably all listeners, do know that. If you want to experiment with this, because this sounds like it solves some of the problems that you have, then I recommend, if you do, first of all, the best approach is to just have a hobby or demo project or an exploration project. But not everybody has programming as a hobby, which I think is perfectly fine. Maybe your business doesn't have internal projects to play around with. Maybe it doesn't give you any time to experiment during work. Then if you want to use it in production, try to find a place which is small and mainly deals with data. Batch services that run in the middle of the night to take some CSV and spit out SQL are probably a good case for this, right? Stuff like that. Try to find a limited use case where you can say data in, data out. Let's try this. And I promise that if you do, this will start jumping out at you way more than you expected. I was surprised by this. So I'm not a functional programmer. I know all the, basically, I can hum along to the song, but I don't know the lyrics, right? I've not done functional programming in earnest ever. But, I read a bunch of stuff and it can make sense to me. And I've used Java and Lambdas and streams, and that's very functional. But the point is, you don't have to come from the I want to use functional programming viewpoint. You can start with, I want to model this data flow. And then you start doing it, and then that makes sense. And then you will notice other places where it makes sense. And because you don't have to apply this to the entire system, it's, I think, kind of easy to start there. But I later noticed that in just other code that I wrote, I realized, oh, wait, this part of the code does, and I'm talking about the last year, only the last year, right? I only had used this like 3 times. I start writing something, I realized, wait a moment, this is just data. I can just model this part as records, and then a bunch of the business logic is just switching over records and doing X, Y, and Z. That doesn't mean the whole system does that, but a portion of it does. And you can also use data and programming in a corner of your larger system. I think it's easier to start with using it as for the whole very small system, and then you realize how it works, and then you can start using it in other subsystems. And I think that's just a natural progression.
Yeah, maybe we're talking too much about that, because if you just show the code, right? So look, there's an interface and implemented by 2 records, and they are mapped to external things, and you have a switch which dispatches between the types, and you can call 2 methods. Then it is everything. Hey, great. Even for Java beginners, it never saw Java before. It will see this. Oh, okay, feels natural, I would say. This is
yes, you're right. We led up to this for like 80 minutes to explain the context.
Yeah, we're just talking,
we're not to use it.
To young enterprise developers who had to deal with data transfer instead of and stuff like that. And do you have a playground project, the GitHub? Is it public, the GitHub sample, or is it something you?
No, yeah. So we can leave a link to that in the show notes.
Just put me the links. So Nikolai had an entire presentation and also a GitHub project where it explains, what where you're using what. Exactly.
So it's like a small little GitHub crawler.
Yeah, exactly.
And it basically uses data and programming as a core. But, that's a good example, actually. GitHub crawler, it's a website crawler.
Yeah.
It takes in HTML. It does a bunch of shit. Does a bunch of stuff.
Yeah.
Creates, some data on the site, like some stats or whatever, and then spits it out. And that's inherently data flowy. And then the whole system just becomes a little bit of a data pipeline.
We are a little bit. It's too interesting again, so we have to stop here. But
oh right, yeah.
But
I'm sorry.
No problem. It was exciting.
I'm already trying to talk fast to make sure we don't run over time.
No problem. We have to meet again. But what I noticed recently, this maybe enums are underused, and enums are great. And I'm misusing enums right now, and I'm even mixing enums with records. And what I need to do, I have to provide complex configuration, some more complex configuration. And I'm using enum as an immutable row in a table, if you think about this. So let's imagine, I don't do it like this, but imagine, let's say we have a connection to a database, right? So I could have enum with the name environment, and the first key could be the name of the environment, and then all the other fields are password not, but username, JDBC, and whatever makes it up. And why in Java code? Because immutable infrastructure as code. Why properties? If we on every change have to ship everything anyway, so it doesn't matter where it is. But the cool story is what you can do. You can even replace the fields in the enum with a Java record because it's nicer. So you have an enum which contains a record which makes sense of the entire configuration. And then you can ask the enum, you get the vector back, the record back, and do something with it, and it works beautifully. So the enums are great, but they are not that much use. I would say everyone talks about records, but enums are old and nice, especially if you combine enums with constructors or with more than this. You can have even static methods on enums, and my enums even creating records or crazy stuff. And I'm just investigating because it works well and it leads to lean code.
Yeah, I think that's actually interesting. So when enums are constants, but as Java classes.
Exactly.
And records are structs, but as Java classes.
Yeah.
So they have the similarity. Like they have the similarity that you enums are like a limited and known number of instances of a specific type.
Yeah.
Records are a known and limited number, well, not necessarily, but you can use them as a known and limited number of types implementing a sealed interface.
Yeah.
So it has a lot of similarity on a different level, on the level of types instead of on the level of instances.
Yeah.
So and enums are cool, like the fact that you can have, as you said, they can have methods on them. You can you can have they can implement interfaces. You really have a lot of class building infrastructure.
The craziest thing I did in my leisure project, actually, I used enums as loggers. And this is crazy, but I had a logger, and I wanted to have a lean logger which prints in colors. And I actually recorded a short about that. And the enum, I had info and warning. Imagine two constants. This info has two fields. One is color, or the escape code from terminal.
Yeah. Yeah.
And then info logs to system out and error to system error. So this is the setup of the enum. And then I write logging or log.warn.out, and it's done. And it works perfectly. This is like 10 lines of code, and all my CLI applications using this right now. No downsides, and I could save lots of code. And yeah, as I said, more experimentation. I mean, we can just.
But this is not enterprisey, Adam. What are you doing? Like, you need SLF4j.
This is my leisure.
Like
this is my leisure. In my leisure, in enterprise clients, I will add Lombok to it, of course, and 2 code generators to make it more sustainable. But in my leisure, it's just this. If I don't get paid, I'm writing 5 lines of code. I get paid. My clients get 2 megabytes of Java code, highly optimized.
Yeah, good.
Cool. Where people can find you on the internet? So
yes. Yeah. So I'm known as NIPAFX, NIPAFX. You can find me under that name on Twitter, on Mastodon, on Blue Sky, on the internet, just nipafx.dev. That's my website. I'm on YouTube. But importantly, I do work for the... God damn it. Sorry. I'm sure I should... usually I swear a lot, by the way. I always try to swear less on Adam's podcast.
Yeah.
But there are notifications going on my desktop.
I don't hear anything, so it's good.
Oh, you aren't?
No.
Okay. Like, maybe the mic doesn't pick them up that well, but they're annoying me. So, right.
You are working, you said.
I'm working at the Java Developer Relationships team at Oracle, and we are doing most of my videos, for example, don't go onto my private YouTube channel, but on the official Java YouTube channel. So youtube.com/Java is a great way to find all kinds of stuff. For example, when we talked about components earlier, my colleague Jose Pomar did a great short about components the other day, so that's like a 1-minute summary of this. I also, coincidentally, did a Jab Cafe on data-oriented programming recently. I also think that was the recent one. So that's one other video that you can take a look at if you want to have a different perspective or just want to hear not my voice explaining it to you again. You can check out Jose's video. He has a different style of explaining stuff, so that's really cool if you're looking for a different angle on this. And so go to youtube.com/Java. And if you are interested in how Java is evolving, if you want to hear about what about the with expressions that I made a throwaway comment about earlier, or what about the assignment deconstruction on assignment, do go to insight.java. It's an aggregator of all the information that pertain to the development of Java in the OpenJDK community. So it pulls interesting emails from the mailing list, the occasional article when a new JEP is announced. It even has an RSS feed for old people. So it's very easy to follow. If you don't want to subscribe to like 70 mailing lists and read all of them, that would be the OpenJDK mailing lists I'm referencing here. There are a lot with a lot of traffic. So just the best stuff goes to insight.java. And if the development of Java as it goes on is interesting to you, you should totally check that out. But be aware that, if you hear about something cool there, it might still take like a year or 2 or 5 until you.
So you should watch the old
episode.
episode, so you will see what is now, right? So
if you don't want to be frustrated,
exactly.
Start watching the Inside Java newscast. Start with the first episode now, and watch a new episode every 2 weeks.
Exactly.
By the time when you watch this, then you now have a decent chance the feature is now final and published, and you can already use it.
The future is now, exactly. And what you also did recently, you killed Maven and Gradle, which is also cool. So it was covered first on the podcast, but then you go more into depth.
Yeah, that was fun. Like people, specifically on Reddit, do not understand the concept of clickbait if they feel like they need to point it out. Okay. That was really fun.
On that note, what I showed, I implemented an funny class loader, which is able to load classes as base64 encoded strings, just to explain what happens. I needed this, and I got a comment that I shouldn't do this. I should use a proper CI/CD environment. And what I will answer maybe is that usually it is really hard, to do this in real world projects because I cannot encode every class in base64 in order to load it. But it is. Did you know actually that if you load a class, the type of the class is also defined by the class loader?
Yeah.
And this is what I wanted to try. Right? Yeah, I loaded the class with the system class loader. And the class with my fake class loader, and then couldn't cast them. I got class cast exception, so Duke was not Duke. And this was the entire purpose, right? So it's just, okay. But thank you a lot, and see you next time. Which topic is hard to tell, because it is never defined in our conversation, but something around with us, I would say, or with, right?
Yeah, but but we have to wait with that a little bit. There's no, that's something on the horizon that I'm really looking forward to, but I don't have a JEP for that yet, so let's wait until there's a JEP. Yeah, but there's other stuff to talk about.
The tagline of the podcast is listen now and use in 2 years, or something like this, right?
Yeah, exactly. That's a good point.
Okay, thank you.
Thank you, Adam. Have a good time.